Hey, welcome back to Ace's World of Math, where we try to bring our world to you. I need a better motto than that. We were talking about a caffeine experiment. So we just, in this 4.3, which is where we're ending things, that's what we're going to end up bringing back. So we decide to go through and run the experiment. 10 students, volunteers were randomly assigned to drink cola with caffeine. Everybody else was assigned to caffeine-free cola. Were their findings statistically significant? That's going to come back over and over and over again. So we have this table here, and this is what we see. So this is the change in pulse rate. So we've already done the final pulse rate minus the initial pulse rate. And this is what happens for people who are on caffeine and people who had the caffeine-free one. So the mean change up over here was 3.2. Mean change for people who were drinking caffeine-free was 2.0. So obviously there seems to be some effect. If you're looking at it, we have a couple negatives, we have a couple zeros. Let's see what goes on. So down here, find the difference in the mean pulse rates for the group. So the difference here between these two groups is 1.2. So the question is, what's your initial reaction to that? Is 1.2 enough to say that caffeine raises your heart rate? So usually the conclusion that people come up with is possibly, but 1.2 isn't a huge difference. I mean, it's 1 beat a minute. Ooh, right? So the question is, how likely is that? The other question is this: what are two possible explanations for what could be happening? So again, students are working through this. They come up with a whole bunch of different things. We'll write them down on the board. The two most popular ones tend to be, obviously, caffeine can't cause the change. That's the whole reason why we're doing the experiment. We were right. Caffeine increases your heart rate. Bam, done. The other thing could be, it's coincidence. It just happens that we're drinking caffeine, but there was something else in that group that led us to think, hey, maybe their heart rate went up because of that. So what we need to try to do here is trying to decide if it's convincing evidence. And the way that we can do convincing evidence is that we're going to do something called a simulation, okay? And simulations run by chance. So if nothing else, if this was just purely by chance, what possibly could have happened? Okay, and that's what we're going for here. Okay. So what we're going to do that is that, so since this is done by chance, we are going to assume this point. We're going to assume that this could have just all happened by chance, and then we're going to see if we do a simulation by with using chance, that it could actually happen. So let's take a look. So what we're going to do for the simulation is that I would give each group or each pair of people 20 index cards. Okay, so on these, I've written down, other way around. I have written down all of those numbers that we saw on that front sheet. 6, 5, 4, them in the right order. So what we end up doing is that we're going to shuffle these things up and we're going to make these into two piles. And these two piles of what we're going to see is going to make up, for example, we're going to have, actually here, let me even label them so it's clearer. There's my caffeine pile, and there's my no caffeine pile. All right, so this one is going to caffeine, this one is going to no caffeine. So on that chart down here, which you can't see because I have mixed, there we go. My chart here, these are the numbers I'd put in the caffeine and the no caffeine. And again, these are all thinking, should probably put this so you can actually read it. So, caffeine. This is the joy of live class. And before you ask, yeah, my class tends to be a little scattered like this too. That's what makes it fun. All right, so anyway, so anything that goes into this caffeine pile, I would write up here in this chart. Everything that I would see down over here in the no caffeine part would go in the bottom chart. So like 2 would go in caffeine, 4 would go in no caffeine. Because again, what we're trying to do is come up with how much is this going to happen purely by chance. So 1 goes there, 1 would go in the caffeine pile, 1 would go in the non-caffeine pile, 4 goes in the caffeine pile, 3 goes in the non-caffeine pile, back and forth and back and forth and back and forth. You get the idea. And then what you're going to do is you're going to take the average of each of those lists. So we're going to take the average of all these caffeine numbers and the average of all these non-caffeine numbers. And we're going to go ahead and then find the difference between the two. All right. So again, this pile goes in the caffeine list. This pile would go in the non-caffeine list. You'd find the means, you subtract them. Great. Then after that, what you'd end up doing is that like here are the 16 that I had in class from the students who were in class last year on this day. And they marked off what they had. So one person had a difference of -3. We had a bunch of people who had 0. We had a bunch of people, somebody here at like 0.6, etc. And each dot here, remember, represents the difference of means from one trial, assuming that the caffeine had no effect. Okay, so if the caffeine had no effect, this is one trial of that. I got a 0. This -2 represents the difference of means of one trial, assuming that if the caffeine had no effect. Okay, so again, each one of those is the important thing. That it's a trial. It's not an actual number. It's a trial of the simulation. I ended up, and I double checked this. I know the graph isn't perfect, but yeah, it kind of looks close. Okay, so this one was like 1.2, 1.3, 1.4. And so we had 3 data points last year that had at least as much as what we had, if not more than what we saw in the experiment. Okay. So what'll end up happening is, so we would say that since we had 3 out of 16, we found 18.75% of our chance. It just happened by coincidence. We could have seen what we had by coincidence. That was really convoluted. I'm sorry. Actually, let's call it like this. Assuming caffeine has no effect on heart rate, there is an 18.75% probability of getting the difference of 1.2 or more purely by chance. Why 1.2? Because that was the number we saw in our experiment. Okay. So again, remember, why 1.2? It was the number, making sure that's there, in our experiment. Okay, so we want to see what are the chances, or what's the probability of seeing what we got in our experiment purely by chance. And the reason why we go bigger than that is because if 1.2 is unlikely to have happened purely by chance, 1.3 and 1.4 would also be probably even less likely. Because again, if this turns out to be a normal curve, the further we get away from what appears to be the mean or the center, the less likely it's going to happen. All right. So there's 2 ways to interpret this depending upon what we see. If the percentage is less than or equal to 5%, yes, it is pretty unlikely to happen on its own. So it's probably due to the caffeine. Okay. This right here is called statistically significant. In our case, the percentage was greater than 5%. So no, it is not that unlikely to happen. And it could be coincident. This is called not statistically significant. And that is a big, big, big thing that we're going to be doing this year. All right. So, end of the simulation. We'll formalize it here in the next video. And then we're almost done with chapter 4. Who would have thought? A third of the chapters in our book almost done. All right, we'll see you soon. Make sure you throw comments, questions, even the odd smart remark down below. We'll see you later.